morning students. I am M. Venkataya. I am assistant professor in the Department of Mechanical Engineering at Vignas Lara Institute of Technology. So now I am going to teach the subject is thermal and hydro prime movers. So in previous class what I have discussed is engine systems, line fuel injection, carburation, ignition, cooling and lubrication. So we have to see here engine system, line fuel injection. So here two different types of injectors is there. That is the mechanical direct injector and second one is the mechanical indirect injection. And the carburation, in the previous class what I have discussed is the carburation, different parts of and different components of carburation, and then the ignition, after completion of that one, cooling and lubrication. So this topic already discussed in the previous class. Now I am going to explain about the topic is engine performance evaluation. This is the last topic of first unit. So the topic is engine performance evaluation. So the engine performance evaluation is the most important in the engines. So how to performance of engine we are discussing here only. So here first of all the main objective. So the engine performance evaluations. So here the main objective is to understand the evaluation of IC engine performance. So to understand the evaluation of internal combustion engine parameters. So performances. So that is we have to understand the evaluation of internal combustion engines performances. So then to calculate the speed, so we have to calculate the speed here of speed of IC engine, fuel consumption, so fuel consumption, then air consumption, So here to calculate, so what we calculate here, the engine speed. So engine speed in the sense of RPM. So this is RPM. RPM means revolution per minute. So we have to calculate speed. This is the main important. So engine speed as well as the fuel consumption. So how much consumed here is that we have to rectify that fuel consumptions as well as the air consumptions, and then to evaluate the exhaust smoke. So to evaluate exhaust smoke. So we have to evaluate this. This is exhaust smoke and exhaust emissions. So here the exhaust emissions means CO2. CO2 means carbon dioxide and SO2 sulfur dioxide. So these are all the emissions. We have to calculate the emission, how much percentage is there, and the exhaust smoke as well as the exhaust emissions. So first of all we want to we want to calculate the speed in RPMs as well as the fuel consumptions and air consumptions. Okay. Next, these are some parameters regarding engine performance parameters. So that is first one is power and mechanical efficiency. So power in the form of units is the watts, and the mechanical efficiency. So how much percentage is there, and the mechanical efficiency is nothing but the brake power, the ratio of the brake power to the indicated power. So then the second one is fuel air ratio. So how much fuel is entering into the cylinder, and the fuel plus air. How much fuel enter into the cylinder as well as the air. So that is the fuel air ratio. How much percentage is entering into the cylinder, we have to calculate it. All the engine performance evaluations. And then the third point is the volumetric efficiency. So we have to calculate the volumetric efficiency. After completion of that one, so fourth one is specific output and specific weight. So what is meant by specific weight? So the specific weight is the specific weight in the units of Newton per meter cube. That means Newton means in the sense of weight. By weight we have to calculate weight, newtons or kg or kilograms. So that is the Newton for meter, the unit of weight to the volume. So that is the meter cube means volume. So we have to finalize we have to calculate the specific output and the specific weight. Okay, after completion of the fourth point, and then the fifth point is specific fuel consumption. So how much fuel consumed here in the cylinder or the engine, we have to calculate the specific fuel consumption. Then thermal efficiency and heat balance. Okay, so the thermal efficiency and heat balance, how much heat is balanced in the engines, we have to calculate. Okay, then the seventh point is the exhaust smoke and emissions. So the exhaust smoke, how much percentage is exhaust smoke is there, and then as well as the emissions, that is carbon dioxide, sulfur dioxide, like that. And the eighth point is effective pressure and torque. So effective pressure and torque. So the what is the pressure? Pressure means the units of pressure is kilopascals. Okay. So first of all, these are all the performance parameters of engine. So the specific engine, the engine processing parameters, and we have to calculate some power and mechanical efficiency. After completion of that one, so fuel air ratio, then volumetric efficiency, after that specific output and specific weight, then specific fuel consumption, then thermal efficiency and heat balance, and seventh one is exhaust smoke and emissions, and the eighth point is effective pressure and torque. These are all the processing, these are all the engine evaluation performance. Okay. Next, this is the performance parameters. The particular applications of the engine decides the relative importance of this processing parameters. So, and performance parameters. So we have to decide the particular application. The particular application of the engine decides the relative importance of those performance parameters. Okay, so for example, we have to take in aircraft engines. So here the aircraft engine, we have to take aircraft engines. So here the most important is the specific weight. So here the specific weight is the more important. So here the for an aircraft, if you take the aircraft engines, so if you take the aircraft engines, here the specific weight is more important. And coming to the industrial engines, specific fuel, here the specific fuel consumption is more important. So two different types of examples is there. First, aircraft engines. If you select the aircraft engine, whenever you select the aircraft engine, then the specific weight is more important. So depends upon the engines. So here that depends upon the engines. Here if you take the aircraft engine, specific weight is more important. After that, if you take industrial engines, then the specific fuel is important. So what is meant by specific weight? Specific weight is the Newton per meter cube. That is weight for volume. Okay. And then the first point is, first of all, the engine performance. The first point is power and mechanical efficiency. Okay, so the power and mechanical efficiency is an IC engine, an internal combustion engine is used to produce mechanical power by consumption of fuel. So by consumption of fuel. Then the power. So the power developed an engine and the measure at the output shaft is called the brake power. Okay. Once again I repeat it. the power developed by an engine and measure at the output shaft is called the brake power. So here the power means power in the sense of two types of powers is there, that is the brake power and indicated power. Okay, so the brake power we are calculating the first of all because of we want to thermal efficiency, that's why we should know the brake power. That brake power is given by the brake power is Vp equal to 2 pi nt by 60. Here the 2 pi is a constant value and the Vp means brake power. Vp means brake power, and here n is the speeds for revolution, minute for revolution, so rpm, so revolution per minute, and then the t is the torque. We have to calculate it. So first of all, the power and mechanical efficiency is an IC engine is used to produce mechanical power by consumption of fuel. After completion of that one, so the power developed by an engine and measure at the output shaft is called the brake power. So the brake power is given by the brake power Vp equal, this is the formula is the most important. This formula brake power equal to 2 pi nt by 60. So we have to see here where the brake power is Vp equal to 2 pi nt by 60. So where T is the torque in Newton meter, the units of torque is in Newton meter, and then n is the rotational speed in minutes, that is rpm. So rotational speed per minute, and Vp is the brake power in watts. Because of power we can what is the units of power is watts. That's why we can the brake power, the power is in units is watts. And then the power and mechanical efficiency. However, while calculating the mechanical efficiency, another factor is there, that is the indicated power. So here what we observe here is the power and mechanical efficiency. So we want finally the mechanical efficiency. That's why here two types of powers is there, that is the brake power, second one is the indicated power. So already brake power 2 pi nt by 60. Then the brake power we are calculating here, the brake power, that is the mechanical calculating the mechanical efficiency. Another factor, that is indicated power. So that indicated power, it is defined as the power developed by constitution of fuel in the engine cylinder. Then it is always more than brake power and is given by, so it is always more than brake power. So we have to, this is the most important point. So it is always more than brake power and is given by the indicated power. We can shortly call it as IP. So that is IP equal to PV NK by IP equal to PV NK by 60. This is the indicated power formula, and P is the mean pressure, V is the displacement of volume of the piston, K is the number of cylinders, and N is the speed in revolution per minute. And then therefore the difference between indicated power and the brake power, the power losses in the mechanical components of the engine due to the friction. So this is why it is mechanical components of engine is that due to the friction it is indicated power, and the losses will be there, that is the friction losses due to friction. So the mechanical efficiency is defined as the ratio of brake power to the ratio of indicated power, that is the E equal to brake power by indicated power. Okay. So next second point is the air fuel ratio. So the air fuel ratio, it is the ratio of mass of fuel to mass or volume of air in mixture. Okay, it is the ratio of mass of a fuel to mass or volume of air in mixture. Okay, then it is the ratio of actual air fuel ratio to that of the psychometric air fuel ratio. So that is the relative ratio lambda equal to A by F. So lambda equal to, that is air fuel ratio, that is air fuel ratio. So it is the ratio of actual air means A to the fuel ratio that of the psychometric air fuel ratio. So that is the lambda equal to A by F. Then actual ratio, actual air fuel ratio by psychometric air fuel ratio. This is the psychometric air fuel ratio, and this one is the actual air fuel ratio. Okay. And then it is the ratio of the third point is the volumetric efficiency. So the volumetric efficiency, it is the ratio of the actual volume of the charge drawn in during the suction stroke. Okay, so during the suction stroke. What is this meaning? It is the ratio of the actual volume. So the actual volume of the charge drawn in during the suction stroke. Then the value of volumetric efficiency of a normal engine lies. So we have to find here, this is a very good percentage is there, that is the value of volumetric efficiency, that is the 70 percentage. That is the normal engine lies 70 and 80 percentage. We have to see here 70 and 80 percentage normal engine lies between the volumetric efficiency is 70 percentage and 80 percentage. But for engines with the forced induction, it may be more than 100%. Okay, we have to see, this is the normal engine lies 70 and 80 percentage. But for engines with forced induction, it may be more than 100%. Okay, it is more than 100%. And then the fourth point is the specific output and the specific weight. So finally the specific output of an engine is defined as the brake power, that is output brake power per unit of piston displacement, and is given by the specific output equal to brake power by area into length. So that is A into L. So actually the specific weight is the what is meant by specific weight is the weight by volume, that is weight by volume. So weight in kg or newtons by volume means meter cube, that is Newton per meter cube. This is the units of specific weight. Okay, so specific weight is the one of the property of fluid, and then the specific weight is similar to the mass density. Okay, so next the specific output and specific weight. The specific weight is defined as the weight of the engine is a kilogram for each brake power developed, and it is an indication of the engine bulk. Okay, so here the engine bulk. So the specific weight Newton for the units Newton per meter cube, that is the newtons in the sense of kilograms or kg, kilograms or kg. So that is the bulk and specific weight. The specific weight, the units is Newton per meter cube. That is the newtons, or we can write kilograms or kg for meter cube. That is the specific weight. Here the main thing is the specific weight plays an important role in the applications such as power plant for aircrafts. So power plants for aircrafts. This is a very good role. It is the specific weight plays an important role in applications such as the power plants for aircrafts. Okay. Then the thermal efficiency and heat balancing. So here the thermal efficiency, finally the brake thermal efficiency BP by MF into CV. So that is the thermal efficiency. The thermal efficiency of an engine is defined as the ratio of the output to that of the chemical energy input in the form of useful supply. Okay, this is the chemical energy input in the form of fuel supply. This is in the form of fuel supply. Okay, it may be based on the brake or indicated powers output. Okay, then the brake thermal efficiency. So brake thermal efficiency that is BP by MF into CV. So where CV is a calorific value of a fuel, that is a kilojoule per kg, and the MF is the mass of the fuel supplied kg per seconds. Okay, so mass fuel supply, that is kg per second. So here the brake thermal efficiency BP by MF into CV, where CV is the calorific value of a fuel, that is a kilojoule per kg, and the MF is mass of the fuel supplied, that is a kg per seconds, that is the units. Okay. And next, the sixth point is the brake specific fuel consumption. We can shortly call it as BSFC. So BSFC, we can shortly call it as BSFC. So it is defined as the amount of fuel consumed for each units of brake power. Okay. Then it is used to compare performance of different engines. So it is used to compare performance of different engines. Okay. Then for most internal combustion engines, so for the most IC engines, the BSFI is nothing but the brake specific fuel consumption will be in the range of 0.5 to 0.6. Okay, the range is the most of internal combustion engines. The brake and brake specific fuel consumption is 0.5 to 0.6 is the range. Ranges between the 0.5 to the 0.6, and then the estimate of brake specific fuel consumption for two-stroke engines. For stroke, we are talking about the two-stroke engines. Ranges from 0.55 to as high as 0.5 pounds. So here we have to see here, this is the most IC engines. The most IC engines is BSFSC is the ranges is 0.5 to 0.6, but in case of two-stroke engines, that is the engine range is 0.55 to 0.8 pounds. Okay, of fuel per horsepower, that is the HP we can call it as horsepower. Okay, horsepower of hour. And then this is the seventh point, that is exhaust smoke and other emissions. So the exhaust smoke and other emissions. Smoke and other emissions are undesirable for public environment. So and smoke, first point is smoke and other emissions are undesirable for public environment. And the second point is because of global warming and emphasis on air pollution, all possible things are tried to keep them low. Okay, so because of the global warming and the emphasis on air pollution, air pollution, of all possible things, or try to keep them as a low. Okay, and then smoke is an indication of incomplete combustion. So if it came the smoke now at the time, that is, it is the indication of incomplete combustion. So it is the indication of incomplete combustion. This point is very important. Okay, and then here are some tips of what you can adopt as air pollution solutions. Air pollution solutions. So here are the some of the tips of that you can adopt as air pollution solutions. Okay, then the eighth, we have to see here some of the points regarding exhaust smoke and other emissions, that is air conditioning systems and electrical regates within the vehicles. So we have to see this point, and air conditioning systems and electrical gates and within the vehicles. For example, sound system and mobile TV systems also take up an energy. Okay, and then so if they are not in use, please turn off, and then turn off them to each and every component, and keep your car in efficient working conditions. Regularly we have to check the conditions, that is, keep your car in efficient working conditions. Okay, and then check the pressure of your car twice regularly. Okay, so we have to check the pressures of your car and our car as usual, like, so twice regularly we have to check the pressure conditions, and then get rid of excess load in your cars. Okay, and then the last point, that is the eighth point, we have to see here the mean effective pressure and torque. So mean effective pressure we can call it as mean effective pressure, MEP, and torque. Okay, then the mean effective pressure is an important parameter for comparing the performance of different engines. Okay, so the mean effective pressure, the mean MEP is an important parameter for comparing the performance of engines. Okay, performance of different engines. It is defined as the average pressure acting over piston throughout a power stroke. Okay, throughout power stroke, it is defined as the average pressure acting over piston throughout a power stroke. Okay, then it is given by the following relation. This relation is, we have to write down. So that is the mean effective pressure, that is P equal to IP means indicated power 60 by LA or K, and this is the mean effective. We have to see here the mean effective pressure and torque. So this is the mean effective pressure, that is the P equal to IP indicated power 60 by LA or K. So where P is the mean effective pressure, IP is the indicated power, and A is the area of the piston, and R is the rotational speed, or we can call it as R in place of N, that is also rotational speed, and K is the number of cylinders, L is the stroke length. So here K is the number of cylinders, and R is the rotational speed. So this is the notation of mean effective pressure and the torque, that is P equal to IP 60 by LA or K, or LAN K. Okay, and then finally the summary is what we have today's class is discussed is, that is engine performance, evaluations, evaluation. Then here 8 processing parameters is there. That is, one is power and mechanical efficiency, and air fuel ratio, and the volumetric efficiency, specific weight and the specific output. Then engine performance of specific weight. After that, the mean effective pressure and torque. Okay, so these are all we are discussing classes. And finally, in this unit regarding the IC engines, that is IC engine topic is completed. In the first previous classes, what we have discussed is the IC engines. What is meant by IC engine? So engine and different types of IC engines, that is internal combustion engine or external combustion engine, we are discussing in the previous classes. After that, valve time, what is the two-stroke engine, working principle of two-stroke engine, as well as working principle of four-stroke engines. Then valve timing and port timing diagrams. After that, air standard cycles. So air standing cycle, 6 cycles is there. One is Carnot cycle, second one is diesel cycle, third one is Otto cycle, fourth one is Stirling cycle, fifth one is Ericsson cycle, and dual cycle. So these are all here. The most important cycle is Carnot cycle, diesel cycle, and Otto cycle. So they given already derivation and as well as the problems also completed. And then engine performance evaluation. Before engine performance evaluation, that is the engine system line injectors. That is 2 types of injectors is there. That is a mechanical direct injector and the mechanical indirect injectors, and the lubrication and cooling and ignition, carburation, different components of carburation already over. And then the last topic is engine performance evaluation. Today's class is engine performance evaluation is also completed, and next class I will go to the second unit. Okay, thank you.